Hey, this is a video I was hoping to help make that ended up mutating into its own thing. On the Stop Killing Games campaign, I think most supporters just need to hear that we're trying to stop games from being destroyed, it's not impossible to do this, and it won't ruin the industry by doing so. Now, I try to dive into the details when people want me to, but my answers don't always satisfy developers. I take more of a bird's eye view approach, where I think if end-of-life plans for games became a requirement, I think developers might be amazed at how many solutions would emerge. But that's not good enough for some. Some people, developers especially, really want more technical details. So what I originally wanted to do was interview a couple developers who could speak on this topic much better than I ever could. But what ended up happening was we had some scope creep, and now we have a full-fledged presentation from two experienced developers, Olive Badger and Matthew Castles from Alderaan Games. I think my introductions of them won't even do them justice, but between the two of them, I think they have a lot of perspective and practical information on how games in the future, and even some in the present, can start having end-of-life plans. So this is by and large a presentation they put together, covering how end-of-life plans could work, and covering some common questions developers have. It's going to get technical, so if you're here for some of my goofier videos, this one isn't for you. I'm just hosting it to get more information out there. But if you're a programmer who's been wanting more details about how we will save games, then this one's for you. Alright, I'll let them take it away.
Hi, I'm Olive Badger, and I have been asked to help with the Stop Killing Games initiative and talk a little bit about some of the common questions that we're seeing from developers. Little bit of background on me. So upfront, I'm not a game developer. I have 5 years of IT experience working in various different parts of the industry, doing data center to internal IT and IT management. After that, I transitioned over to software development, where I've done a decent amount of embedded software development for drones and then moved into full stack development. I've even done a little bit of DevOps and project management for a small startup. I do have a YouTube channel that just kind of popped off with this whole thing. It's just Olive Badger. Now, that said, this presentation was put together not just by me, but also Matthew from Alderaan Games, who is a game developer. I'll let him introduce himself.
Hey everybody, how's it going? My name is Matthew Castles. I'm the founder of Alderaan Games. I've been making and modding games for the past 15 years. In 2016, I made my own game studio, which is completely independent. We also made our own platform replacement to Steam. And in 2019, we launched a dinosaur survival game called Path of Titans. So I'm going to use this game as an example on how we're going to do an end-of-life plan and some issues we'll need to fix when end-of-lifing the game. I'll talk more about that towards the end.
Thank you, Matt. So let's get into this PowerPoint presentation where we'll talk about the different ways you can stop killing games as a game developer. This will start off talking about the broad concepts, then get more into specifics as we move on. First up, what are some possible methods for end-of-lifing your game? Before we dive into the technical details, let's establish the three primary approaches for ending the life of your game responsibly. The method you choose will depend heavily on your game's architecture, technical constraints, and business considerations. So first up, we have option 1, which is to release private server files or support peer-to-peer sessions. This is often considered to be the gold standard for game preservation. When you release private server files, you're essentially giving the community the tools they need to host their own multiplayer servers. The key here is that you can strip out code that's no longer needed. Things like payment processing, analytics, and proprietary algorithms, all while keeping the core gameplay functionality intact. Make sure your game includes a direct IP connect option, as this would become crucial when centralized matchmaking is no longer available. All right, next up at option 2 would be to release the source code. This approach provides maximum flexibility for the community, but does require careful consideration of what you're releasing. You can release both game and server source code under a limited license where players can only use the code to keep the game functional and not for commercial use purposes. This allows the community to fix bugs and maintain missing features after end of life. However, other options are generally preferred because they keep the game functional without requiring additional work from players. And for option 3, you can release feature-complete games with save transfers. This approach works particularly well for games with significant online components that can be converted to offline experiences. For example, you release a standalone version that's free for owners of the original game, and importantly, you would allow save transfers from the online version to the standalone version. This would ensure that players don't lose their progress when the transition happens. And so let's take a look at a real-world example of how option 1 worked. A Spellbreak, developed by Proletariat, was a multiplayer battle royale game available on PC, PS4, Xbox One, and Nintendo Switch. When they ended support in January of 2023, they took the responsible approach of releasing a private server version for PC Windows users available for free. This is exactly what we mean by preserving the core gameplay experience. Even though the official servers went dark, players could continue to enjoy the game that they had purchased. The private server maintained the essential multiplayer functionality while removing the infrastructure burden from the developers. All right, so here's an example of option 2, Delist, which was published by Warner Bros. Games and available on PC, iOS, and Android, which ended support on February 27th of 2020. The developers made the remarkable decision to release the source code to GitHub under a CC0 license, which is essentially public domain. This approach gave the community complete freedom to maintain, modify, and improve the game. While it requires more technical knowledge from the community, it does ensure the longest possible lifespan for the game, since dedicated fans can fix issues, add features, and port the game to new platforms as needed. And here's another strong example of open sourcing. It's called Caller's Bane, formerly known as Scrolls, developed by Mojang. Available on PC, macOS, and Android, it ended support on February 13th, 2018, but was officially resurrected as Caller's Bane and made open source. What makes this case particularly interesting is that they released both the game client and server files for download. The free client can join community servers and anybody can host a server. This creates a distributed ecosystem where the game's survival doesn't depend on any single entity. If one server goes down, for example, others can continue serving the community. Pretty cool, right? Nintendo's Animal Crossing Pocket Camp provides an excellent example of option 3. This mobile game ended support on November 28th, 2024, but Nintendo released Animal Crossing Pocket Camp Complete as a replacement. This is a masterclass in player-friendly transitions. They replaced the free-to-play, microtransaction-heavy online version with a paid offline version that removes microtransactions entirely. For a flat $20 purchase, players get access to all content that was previously behind the paywalls. Most importantly, they allowed users to transfer their save data, ensuring that years of progress weren't lost. This approach respects both players' time, investment, and their financial investment in the game. All right, now that we've seen some successful examples, let's step back and look at the broader context of what we're trying to achieve here. Game preservation isn't just about keeping old games running, it's about respecting the culture and artistic value of interactive entertainment, honoring players' investments of time and money, and ensuring that future generations can experience and learn from the games we create today. Creating an effective end-of-life plan requires thorough documentation and clear communication. Let me walk you through through the essential components here. So first, communicate to players that the game has an end-of-life plan. This should be done early and often. Ideally, players should know from the time of purchase that you've thought about preservation. Contact players and let them know how long the end-of-life patch will be available for download. Give them a realistic timeline. For example, will it be available for 6 months, 2 years? Players need time to prepare. And then list out supported features that would continue working, such as single-player modes, direct connect options, and LAN play. Be very specific about what will still function. List out features that would be removed, such as matchmaking, leaderboards, or cloud services. Transparency here prevents player frustration. Include documentation on installing, running, or playing the game, especially if setup becomes more complex once official support ends. Consider that players may be setting this up years later on completely different hardware. Do your best to document any known bugs or workarounds that the community should be aware of. This saves everyone time and frustration. And if you own the IP, provide a clear written statement allowing for non-commercial use such as community servers or mods. This legal clarity is crucial for community preservation efforts. If a game can be modded, consider releasing tools or documentation for modders to extend its life. The modding community is often your best ally in long-term preservation. And finally, communicate what hardware or OS might be needed for the end-of-life version. If your server software runs on a different platform than the client, make this as clear as possible. All right, so what suggestions would we be able to give for existing games to move over to support their game at end of life? Now, please keep in mind these are just suggestions and won't be possible for all existing games due to existing constraints. Stop Killing Games is mostly focused on future game designs. Well, for games that are already released but haven't planned for end of life, here are the most effective strategies. Release server software or tools that allow players to host their own servers. Again, this is the gold standard for game preservation. You can provide server binaries that allow dedicated community members to host their own servers, and this requires careful preparation to remove all the proprietary code and secrets while maintaining core functionality. Focus on creating packages that work out of the box with minimal technical knowledge required. Open source key components so the community can maintain the game independently, and consider open sourcing non-proprietary game logic, networking, code, and tools. This allows the community to maintain and improve the game independently. So start with less sensitive components like UI systems, utility libraries, or game balance configurations. Try to avoid releasing anything containing trade secrets, licensed third-party code, or proprietary algorithms. Do your best to provide documentation and assets to help fan projects continue the experience. You can also create comprehensive guides for server setup, configuration, and troubleshooting. Include game assets that players might need for custom content creation, textures, models, sound effects, and level editors. This documentation becomes invaluable when your official support ends and helps ensure knowledge transfer to community maintainers. Create official mod support or expansion tools before shutdown. Implement robust modding tools and APIs before shutdown announcement. This gives the community tools to extend the game's lifespan through custom content and modifications. Simple scripting APIs, level editors, and asset replacement tools can dramatically extend a game's community lifespan. Release a single-player or offline version that can preserve core gameplay. Create offline versions that preserve core gameplay mechanics without requiring server connectivity. You can strip out multiplayer dependencies and convert online features to local alternatives where possible. Note that this only really applies to games that were already single-player to start with. If your game has multiplayer support, you should do your best to keep this functionality working at end of life. We're not asking to convert multiplayer into a single-player experience. The key key to successful game preservation is planning ahead. When you design preservation into your game from the beginning, rather than trying to retrofit it later, you save significant time, money, and technical complexity. So let's discuss how to build these systems from the ground up. Right, so how do developers reduce cost for an end-of-life plan? That's a great question. So cost reduction starts with smart decisions during development. Option 1 would be to avoid bad licensing agreements. Prefer agreements which don't have restrictions on giving binary versions of code out to players and don't have time limits. When you're negotiating middleware licenses, think about the end-of-life scenario. Some licenses explicitly prohibit redistribution or have clauses that make preservation expensive or impossible. Option 2 would be to use open standards and open source solutions that don't have these types of restrictions. Instead of using Amazon or a serverless database, you may prefer more open options like MySQL, or create a transition plan where MySQL can be used for community servers while Aurora is used at scale during active development. This gives you flexibility to scale during active development while ensuring community servers can run on accessible technology. Option 3 would be to code the game assuming services can fail or be removed. Make sure the game can handle service failures gracefully instead of crashing or showing cryptic error messages. This defensive programming approach not only helps with preservation, but also makes your game more robust during active development. All right, so what is the minimum viable build or setup that should be preserved? The minimum viable build is going to depend on your specific game, but there are some general principles to follow. All core features and functionality should still be present if these features were being used. This includes single player modes, multiplayer functionality, and local play or co-op features. The key word here is core. If a feature was central to the game experience, it needs to work in the preserved version. Some extra features and functionality can be removed depending on the game, particularly those not needed for that core gameplay. Examples include leaderboards, online ranking systems, and other microservices not needed for the core gameplay loop, like payments, account moderation, or anti-cheat systems. These are nice to have features that enhance the experience but aren't essential for the game to function. The goal is to preserve the essence of what made your game enjoyable while removing the infrastructure burden that makes long-term support unsustainable. All right, so what does it take to replicate your server environment locally for preservation? That's a great question. Replicating your server environment locally involves 3 main steps. Step 1 would be environment standardization. This includes containerization strategy, dependency documentation, configuration management, and resource requirements. You need to document exactly what your server needs to run, including operating system requirements, memory usage, CPU requirements, and any special dependencies. Step 2 is technical infrastructure replication. This covers database setup and migration, service coordination, network configuration, and monitoring and logging. The goal is to take your complex distributed production environment and create a simplified version that can run on community hardware. Step 3 would be community support tools. This includes automated setup scripts, development and testing tools, backup and recovery procedures, and performance optimization guidance. Now remember, community members may not have your level of technical expertise, so the easier you make this process, the more likely your game is to survive long term. All right, so next up, we're going to talk about virtual machines and Docker. So what are virtual machines and Docker, and how do they help developers end their games easier? Virtualization and containerization technologies significantly simplify game server distribution and management for community hosting. Virtual machines provide complete, isolated environments that include everything needed to run game servers. You can package the operating system, game server software, database, and configurations into a single VM image that works identically regardless of the host hardware. This solves the it works on my machine problem by giving the community an exact replica of your development environment. Docker containers solve the same problem but with less overhead. Docker containers include all necessary libraries, configurations, and dependencies. A containerized game server will run identically on any system that supports Docker, eliminating compatibility issues. Docker is generally more efficient than full virtual machines and easy for communities to manage. All right, so are there reusable patterns like modular designs, toggleable auth, or offline fallbacks that could be integrated now or in the future? Well, yes, I'm glad you asked. There are several architectural patterns that make end-of-life transitions much smoother. For example, server abstraction pattern would create interface layers for swapping cloud services with local implementations. This would allow you to use sophisticated cloud services during active development, but switch to simpler local alternatives for preservation. You could use feature toggle architecture to implement a comprehensive flagging system for all cloud dependencies. This would let you selectively disable features that can't be preserved while keeping core functionality intact. Another option available to you would be dependency injection, using automatic service swapping based on environment. So your game can automatically detect whether it's running in production or preservation mode and then adjust accordingly. You can use plugin-based architecture and design your game with modular components where complex features can be completely removed without breaking core functionality. There's also offline first data flow to always save locally first and sync to the cloud as an enhancement. This ensures the game continues to work even when cloud services are unavailable. You could use progressive enhancement, which is a design feature to work offline but enhance when online. Think of online features as bonuses rather than requirements. Queues online actions for when connectivity returns. This allows the game to continue functioning during network outages and makes the transition to offline mode pretty seamless. So what should we do when the game fails? Should it fail gracefully? I mean, absolutely yes. Your game should never crash and show stuck loading screens or display cryptic error messages when servers go down. This is just fundamental to good user experience and essential for game preservation as well. The game needs its end-of-life build tested to ensure graceful error handling. So this means implementing proper timeout mechanisms, clear error messages that explain what's happening, and fallback modes that let players continue enjoying the game even when online services aren't available. Think of server unavailability not as a failure state, but as an expected operating condition that your game should handle professionally. All right, so let's look at some of the best practices for removing credentials, API keys, telemetry code, etc., from your end-of-life builds. Security is crucial when releasing community builds, and here are 3 approaches. Option 1 would be automated detection and removal. You can use tools like GetGuardian, Trufflehog, or Secret Scanner to identify credentials in your codebase. Add build processes that automatically remove or replace secrets during compilation. Create build processes that automatically generate configuration templates with placeholder values instead of real credentials. But be aware that some libraries include default API keys or demo credentials that should be removed and replaced. Option 2 would be manual review. Implement code review processes focused on credential identification. Tools like strings or hexdump can identify text that shouldn't be present in community builds. Test community builds in isolated environments to verify they don't use production credentials. Review all documentation and comments for references to sensitive information that should ultimately be removed. Option 3 would be replacement and abstraction. So you can convert hard-coded credentials to environment variables, abstract credential usage behind configuration interfaces, and replace services that require credentials with mock implementations. Ensure that your default credentials are documented as insecure examples that must be changed. The goal is to ensure that your community release can't accidentally connect to production services or expose sensitive information. And so how can conditional compilation or environment-specific codes such as if diffs or build flags help prepare for shutdown? Well, conditional compilation is one of your most powerful tools for preservation planning. So option 1 would be graceful degradation planning using conditional compilation to prepare fallback modes that can be activated when services shut down. You might have if-diff offline mode blocks that enable local leaderboards, bot opponents, or single-player alternatives to multiplayer functions. This allows the game to continue functioning even after servers go offline. Option 2 would be with a DRM and authentication bypass. When preparing for preservation, you can use conditional compilation to create builds with authentication checks disabled or have DRM removed. Flags like if-diff preservation build can activate code paths that bypass server-dependent authentication while maintaining the original gameplay experience. And the beauty of this approach is that you can develop and test these preservation modes throughout your development cycle, ensuring that they work correctly when the time comes to use them. How do you document your game's server stack so players can replicate it later? We all hate documentation, but it's a necessary evil, even in game preservation. Comprehensive documentation is essential for successful community preservation. So what are some things that we'd recommend that you do? Well, you can create simple architecture diagrams with clear arrows and labels that show how different components connect and communicate. You can provide a one-page setup, a flowchart showing the design flow from initial installation to a running server. Include folder structure visuals that are easy to display so community members understand how to organize these files. Write step-by-step numbered processes for installation, configuration, and troubleshooting common issues. Document your API endpoints and their usage if your game uses internal APIs for communication between components. You can also provide Docker setup instructions if you're using containerization for distribution. You're also going to want to list system and hardware specifications, including minimum requirements, recommended specifications, and any special hardware considerations. Remember, the people setting up these servers in the future may not be professional developers, so clarity and completeness are much more important than technical sophistication. All right, so now let's move into the practical implementation details. We've covered the theory and planning, so now let's talk about how to actually build these systems and handle the technical challenges that you might encounter. Really common question is, how would players host servers when your code and setup is really complicated? Well, when your server architecture is complex, you have two main options for simplifying community hosting. Option 1 would be virtual machines. Virtual machines can be set up in software like VirtualBox, Parallels, or Hyper-V. This can remove complexity around server environments by providing a complete, ready-to-run environment. Option 2 would be Docker. A Docker file can be used by Docker to easily set up services on almost any PC. Docker containers are generally more efficient than full virtual machines and easier for communities to manage. You can define your entire server stack in a Docker Compose file that automatically sets up all the necessary services with a single command. Both approaches hide the complexity of your server architecture behind a simple interface that community members can use without a deep technical knowledge. All right, so what happens if your game is tied to a platform ecosystem like Steam or PSN or Xbox Live? Well, platform integration doesn't have to be a barrier to preservation. For example, you could retain existing Steam, PSN, Xbox Live services, which most of these services will still require multiplayer games to use their features. And since those will remain online, you could still use them. Just remove any dependencies on publisher-owned or required services that won't be available after end of life. Option 2 would be direct connect options, and providing options in-game, such as using a direct connect IP option or LAN server functionality. This gives players an alternative when platform-specific matchmaking isn't available or becomes unreliable. Option 3, you could handle legacy platform cases, for example, with Xbox 360 games where Xbox Live no longer exists in its original form. LAN and system link options work great. Players can use VPNs to still play over the internet, even though the original Xbox Live infrastructure is no longer available. The key here is providing multiple connection methods so that your game isn't dependent on any single service. All right, so locked time events. What if your core gameplay depends on locked time events? Time-locked events present special challenges, but there are practical solutions. Option 1 would be using local time. You can use a driver coding pattern and have a fallback path where events could be simulated locally or run on a rotation at specific times based on the user's system clock. This allows events to continue happening even without server coordination. Next up would be community server setting. Server settings could be provided for community servers to define events, their timing, and duration. This gives community server administrators control over the event schedule and allows them to adapt it to their player base. The goal is to preserve the gameplay experience that events provide, even if the exact timing and coordination mechanisms need to change a little bit. All right, I hear ya. Can matchmaking be replaced with LAN or peer-to-peer solutions? Yes, but you have two approaches that are going to be dependent on technical constraints. Option 1 would be to continue to support matchmaking by giving out a server binary which lets players host a master server that holds a list of IPs for matchmaking or spins up local server processes with something like Docker. This maintains the familiar matchmaking experience while removing infrastructure dependency. Option 2 would be remove matchmaking entirely. You can support direct IP or LAN connects instead. While this requires more technical knowledge from players, it's simpler to implement and maintain. Many classic games worked this way successfully for years. So consider your player base's technical sophistication when choosing between these approaches. All right, so what if the game server requires authoritative logic for fairness? That's a good question. Authoritative servers are important for competitive integrity, and guess what? You can maintain this in preservation. Option 1 would be community server with authoritative logic. So you could release a server binary where community servers can be instanced and be authoritative for their instance or realm. You could let players direct connect via IP or LAN, and each community server would maintain fair play within its own ecosystem. The other option would be peer-to-peer authority. Have a player picked to be the host who access the authoritative server and can spectate the game while it's playing to avoid host advantage bias. This approach works well for smaller scale multiplayer games where community servers might be overkill. The key here is maintaining competitive integrity within whatever hosting model you choose, even if the scale is smaller than your original centralized approach. So, can you automate having an end-of-life build and have a normal build while developing your game with CI/CD? Well, absolutely. And this is highly recommended. Build flags are your friend here. As mentioned in previous slides, build flags such as sunset patch can be used, which strip out sections of code. This will let you ship a sunset version of your server executable to QA for local testing and running test plans. By integrating this into your CI/CD pipeline, you can automatically test both your production build and your preservation build with every code change. This ensures that when the time comes to release the preservation build, you know it works correctly because it's been tested throughout the development process. This approach also lets your QA team test preservation scenarios during development, catching issues early when they're easier and much cheaper to fix. What tooling can you provide to the community to set up servers like scripts, Docker files, and config generators? The more tooling you provide, the more likely your game is to survive in the community. So one option would be to release a self-contained server package where you could include simplified versions of your services, a lightweight database like SQLite, simple web server for admin interfaces, and all game logic in one downloadable package. Aim for download, extract, and run type of simplicity. Another option would be to provide Kubernetes manifests or Docker Compose files for easier deployment. For technically sophisticated community members, you could provide orchestration files that automate complex deployments. Docker Compose files can define multi-container setups that replicate your architecture at a smaller scale. Another option would be to create installation scripts. You could provide automated installation scripts that handle service setup, database initialization, and configuration file generation with dependency installation. You could make these scripts work on common platforms like Ubuntu, Windows Server, Mac OS, etc., etc. You could also offer a cloud agnostic version. You could design community versions to work on any hosting platform, from Raspberry Pi servers in someone's home to small VPS instances on any cloud provider. You'll want to avoid dependencies on specific cloud features though, which will kind of lead us into this next slide, which is what are the major differences between hosting a game server on Amazon compared to locally at home. Well, understanding these differences helps you design the servers that work in both environments. So we're going to go ahead and look into that. First off is distance and infrastructure. So cloud servers are hosted in data centers with uninterruptible power supplies, backups, and staff on standby to provide remote hand support if something goes wrong. Home servers deal with residential internet, power outages, and limited technical support. Next up would be bandwidth. Enterprise servers have much more bandwidth, such as 10 gigabit connections, which won't be needed at end of life. Community servers typically run on residential internet connections with much lower upload speeds. You also have 99% uptime and scaling. Cloud deployments use extra services for failover, load balancing, and complex scaling to handle millions of users. Community servers are designed for smaller local communities, and they really don't need this complexity. So design your community servers to work well within these constraints rather than trying to replicate your production environment exactly. But let's say your game uses a lot of complicated services such as AWS, Google Cloud, and other microservices. What do you do then? Well, these complex service infrastructures can be simplified for community hosting. So first, you could remove the microservices that are not needed. This will help reduce the surface area of work needed for the game to be functional. Most microservices are really not needed at end of life. Things, again, like payment processing, analytics, and account management really become unnecessary. You could also use best practices such as infrastructure as code. Use a descriptive model of what services need to be deployed so they are easily recreated at end of life by the community. Tools like Terraform or Kubernetes manifest can help with this. Again, to bring it back to Docker, you can use that technology like Docker. Docker can easily spin up a bunch of containers to host services for players. It also removes dependencies on the operating system and environmental complexity. And finally, you could provide players documentation and files, allowing them to set up their own cloud account like AWS and set up servers that way. Some community members may prefer to run servers on cloud infrastructure rather than home hardware. All right, so here's a practical list of services you can typically remove for end-of-life builds. I'm not going to read this whole thing, so go ahead and pause the screen. I encourage you to take a look through all of these because this is a lot. This is a lot that can be removed out of your current system and your current code and current setup to make an end-of-life build work. All right, so what if you use PlayFab or GameSparks? How do you end of life your game if you are using these types of managed backends? Well, managed backends require special consideration for end of life planning. So here are some key strategies to consider. You could use feature mapping and prioritization. You'll want to document every BAS feature your game uses and categorize them by importance. Essential features like player authentication and game saves will need a replacement, while nice to have features like detailed analytics can be removed entirely. You want to create a comprehensive list mapping each BAS feature to either a local replacement or a removal plan. Data export and migration, well, you can export all critical data before service termination. This includes player profiles, game progress, leaderboards, user-generated content, and configuration data. Most BaaS providers offer data export tools, but you may need custom scripts to extract everything in usable formats for community servers. Could also use progressive decoupling. Start by reducing BaaS dependencies in updates leading up to the shutdown. You'll replace complex BaaS features with simpler local alternatives, gradually allowing you to test each change and get community feedback before final shutdown. You want to also try to utilize local API development. Create local APIs that replicate essential BaaS functions with simplified implementations. A local player data API might use SQLite instead of cloud databases, and local leaderboards might be server-specific rather than global. All right, so can dependency injection or other modular architecture help isolate what needs to be removed or replaced at end of life? Yes. Absolutely. Good architectural patterns make end-of-life transitions so much smoother. Service abstraction and swapping, as an example, would mean dependency injection allows you to abstract external services behind interfaces that can be easily swapped during end-of-life preparation. Authentication services, analytics platforms, and cloud storage can be replaced with local implementations without changing core game logic. Configuration-driven component selection with proper dependency injection, you can easily select implementations to use based on configuration files or build settings. Production builds might use cloud services, while community builds could use local alternatives. Testing and isolation. So dependency injection makes it easier to test community builds by allowing you to inject mock implementations during development and testing phases. This helps identify issues before final release. Cleaner code organization. Well-designed dependency injection leads to cleaner separation of concerns, making it easier to identify what components are safe to remove and what dependencies each feature requires. All right, so how do you test the final state of your game in a post-server world to confirm that it behaves as expected? Well, testing your end-of-life build is crucial for a smooth transition. You can use feature flags to test community builds while production services are still available. You can gradually enable community-compatible features and disable problematic ones during transition periods. This allows you to test preservation mode while your game is still live. Build defines can be used to build a special version of your game for end of life that has authentication checks disabled and cloud dependency removed. This gives you a clean testing environment that matches what the community will actually use. With test plans, your quality assurance team can run through an end-of-life test plan to make sure your game functions throughout the development process. Create specific test cases for server failure scenarios, offline mode functionality, and community server connections. Regular testing ensures that when the time comes to release your preservation build, you know it works correctly because it's been validated throughout development. And so, can you create a community server binary with stripped down version for player hosting at end of life? Well, absolutely. And this is often the most practical approach for preservation. Feature reduction and optimization strip out features that aren't essential for core gameplay or that require proprietary services. You'll want to remove analytics systems, complex monetization features, advanced anti-cheat integration, and features that depend on unavailable third-party services. Dependency building. You'll want to include all necessary libraries, runtime dependencies, and configuration files to minimize external requirements. Use static linking where possible to reduce dependency conflicts and simplify deployment. Configuration externalization. You'll want to move all customizable settings to external configuration files rather than hard-coded values. This would allow administrators to customize servers without needing source code access or recompilation. resource optimization. You'll want to optimize binaries for typical community hosting scenarios, which often have limited resources. Use efficient algorithms, reduce memory usage, and optimize for single server rather than distributed deployment scenarios. How do you remove login or DRM from games that prevent you from running offline? Well, removing authentication barriers is obviously pretty essential for preservation. So you'll want to replace authentication with always success functions. Modify login systems to automatically succeed without server verification. Remove DRM license checks and strip out periodic license verification and online validation requirements. You'll also want to eliminate periodic online verification by removing any systems that require regular check-ins with authentication servers. You can enable local user management and store profiles in local files or use a local storage implementation with simple username-only login systems that don't require server verification. You'll also want to use build flags for clean separation. Implement conditional compilation so you can cleanly separate authentication code from core game logic. You'll also want to test offline functionality to ensure the game starts without internet, shows no license errors, and local saves work properly. Then you'll want to communicate changes clearly. Label builds as something like Community Edition, no account required, or all DRM removed for preservation, and update license agreements accordingly. All right, so now let's address one of the most complex aspects of game preservation, which is handling player data and security considerations when transitioning to community-hosted infrastructure. One question we see fairly often is how do you handle removing anti-cheat and other services like BattlEye for end of life? Well, anti-cheat services require special consideration because they often have licensing and technical dependencies. For example, BattlEye. BattlEye has options to run the game without it by using the game executable directly. So you can patch out BattlEye code in your game executable with a define such as if with BattlEye client. You can also provide a command line argument players can use, such as no to disable it entirely. There are some cost considerations. BattlEye charges a monthly fee per user playing the game. Since it's removed in the preservation build, there will be no ongoing cost, which is important for community sustainability. Community anti-cheat alternatives like community servers can take cheating into their own hands by using IP whitelists, firewall rules, and community moderation. While not as sophisticated as commercial anti-cheat, these methods can be very effective for small community servers. The key is ensuring the game remains playable and enjoyable even without enterprise-level anti-cheat protection. Right, so how do you handle data at end of life and protect user privacy since, you can't give out players copies of databases or private information? Well, player data privacy is crucial, and there are two main approaches that you could use here. The first option would be to alter the game to pull from local databases. You could convert player and account save data to be stored locally on each player's machine. Set up in-game purchases to always return as owned, eliminating the need for server verification. This approach gives players control over their own data while protecting everyone's privacy. The other option you could try is to allow users to change database endpoints. Expose configuration options to allow for a community to manage a shared database. This maintains the social aspects of shared progression and leaderboards while keeping the infrastructure community controlled. Both approaches respect player privacy while ensuring the game remains functional. The choice between them depends on whether your game benefits more from individual data ownership or shared community progression. Well, that's all great, but how do we patch out authentication servers or have players still connect even if the game is designed to be online only? Well, converting online only games to work offline does require very careful planning. There are a couple of options though. So option one would be to utilize a local save file. You can use locally generated unique identifiers and names which can be used in a LAN context or VPN context for identifying players while removing the need for accounts. This works well for games where player identity is primarily about game state rather than social interaction. Option 2 would be account database. Provide an empty schema file for your database so it can be hosted by the community or on community servers. You could provide a setting in the game which controls which IP it connects to, such as in a config file. This maintains the social aspects of the game while making the infrastructure community controlled. Ultimately, the goal is to preserve the gameplay experience while removing dependencies on your proprietary infrastructure. All right, so what if you're using a programming language for your game that doesn't compile into a binary like JavaScript or Python? Interpreted languages do present special challenges, but they do have several solutions. The first option would be code obfuscation. You can use obfuscation tools to make source code difficult to read while maintaining functionality. Tools like Uglify.js for JavaScript or PyArmor for Python can scramble variable names, remove comments, and restructure code to make it less readable. Another option would be selective code release. Release only the minimum necessary code for server functionality. Keep complex game logic, proprietary algorithms, and business logic in separate modules that aren't included in community releases. You want to focus on releasing networking, basic game state management, and configuration handling. Option 3 would be binary compilation options. Use tools that compile interpreted languages to binary executables, like PyInstaller for Python, PKG for Node.js, or Electron for JavaScript to create distributable binaries that hide source code and maintain functionality. Last up would be licensing and legal protection. You could release source code under restrictive licenses that allow community use but prevent commercial exploitation. Creative Commons licenses or custom licenses can provide legal protection even when source code is visible. So what are some alternative distribution methods that you could use if you don't want to give out your source code or your server files? So if you need to protect your source code, there are several different approaches. Option 1 would be container-based distribution. We've talked about Docker a lot, but you can distribute complete Docker containers that include the source code, but make extraction more difficult. While technically possible to extract, it requires additional technical knowledge and effort. Option 2 would be using modular architecture. Design your server architecture with clear separation between core game logic and infrastructure code. You can open source infrastructure components while keeping game logic proprietary. Option 3 would be configuration-driven logic. So you'll move as much game logic as possible into configuration files rather than source code. This allows community customization without exposing implementation details. You could also use option 4, which is API-based architecture. You'd create an API-based architecture where game logic runs in separate protected services while community-hosted components handle networking and basic server management. Option 5 would be documentation and support. Provide excellent documentation and support to encourage proper use of your code rather than modification. Well-documented, easy-to-use code reduces the incentive for communities to modify or reverse engineer it. All right, so what if I have secrets or private keys in my server binaries when releasing them? Like how would you handle this? So you could use compiler flags or build flags. This would be your primary tool here. You can use these tools to remove features or secrets from your code base. You might provide an argument like sunset patch, which will define sunset patch variable, which you can then use via if diffs to run a section of code or otherwise back to the standard code. This approach lets you maintain one code base with different build configurations for production and community releases. The community build can use placeholder credentials, disable features that require secrets, or use entirely different code paths that don't need sensitive information. The key here is planning this architecture from the beginning rather than trying to strip secrets out of an existing code base at the end of development. All right, so what would be the safest way to release server binaries if you can't share the whole source code? This will be in a couple different parts. So first part would be security preparation. You'll want comprehensive security auditing, use static analysis tools to identify potential vulnerabilities, dependency scanners to check for known security issues, and penetration testing to validate security measures. Dependency security management, you'll want to use tools like OWASP dependency check Snike, or similar security scanning platforms to identify and address security issues. You'll also want to use attack surface minimization. You'll want to reduce attack surface by removing unnecessary features, disabling unused services, implementing input validation and sanitization, and using minimal privilege principles for all operations. You'll also want a secure build environment. Ensure binaries are built in secure, controlled environments using verified source code, signed build tools, and isolated build systems that prevent tampering during compilation. What's the safest way to release server binaries if you can't share the whole source? Part 2. All right, so you'll want to keep in mind the legal and compliant framework. You want to conduct comprehensive audits of all included components to verify license compatibility with community distribution. Remove any components with restrictive licenses that prohibit redistribution or require ongoing payments. You'll want to do an intellectual property review to review binaries for proprietary algorithms, trade secrets, and confidential information that shouldn't be distributed. With liability management, you'll want to consider the terms that limit your responsibility for community-hosted servers while protecting your intellectual property. You'll want to use export control compliance. Consider export control regulations if redistributing internationally, especially for games with encryption or other controlled technologies. All right, so part 3 would be distribution and security. So digital signing and authentication. Sign all binaries with valid code signing certificates to ensure authenticity and prevent tampering. Use secure, reputable distribution channels with proper access controls. Consider multiple distribution methods to ensure availability while maintaining security. Version control and tracking. Maintain clear version control with detailed changelogs and security advisories. Implement mechanisms to revoke or update binaries if security issues are discovered. And community communication. Establish clear communication channels for security issues and provide procedures for reporting and addressing security vulnerabilities discovered by community members. All right, now let's discuss the practical aspects of actually executing your end-of-life plan. This is where all your preparation pays off, but there are still important considerations for the transition period. So how do you communicate to your players that the final build is unsupported or community maintained? Well, first off, clear communication is essential for a successful transition. In-game messaging, you can add prominent but non-intrusive notifications within the game itself. A banner or pop-up on the main menu stating, "This is the final official release, future updates will be community-driven," ensures players understand the transition. Could use version naming and branding. Use clear version identifiers that signal the transition. The final official build might be labeled something like Final Edition or Legacy Version, while community builds could use naming like Community Edition or Preservation Build. Documentation and README files. Include comprehensive documentation with the final build explaining the game's status, what features may no longer work, and where players can find community support. Community handoff messaging. Frame the transition positively rather than as an abandonment. Emphasize how this ensures the game's long-term survival. Technical disclaimers. Be upfront about limitations. Online features may stop working at any time, or no official technical support is available, or even compatibility with future operating systems is not guaranteed. Resource signposting. Provide clear directions to community resources, forums, Discord servers, fan sites, or GitHub repositories where players can find help, mods, or continued development. Make these resources easily discoverable within the game itself. Farewell content. Consider adding special content that acknowledges the game's journey, perhaps as a credit sequence thanking the community or a message from the development team. This creates a sense of closure while celebrating your game's legacy. And legal clarity. Include clear statements about what players can and cannot do with the final build. This is important. All right, so can you delist your game from a store but still let owners re-download it? Yes, most platforms support this approach. So with Steam, for example, Steam will let you still have existing offline files that players can back up if you opt out of DRM. Players who already own the game can continue to download and play it even if it's no longer available for purchase. With consoles, most consoles will still let you re-download an existing game you own even if the store page is unavailable and the game is not being sold to new customers. This approach protects existing players while preventing new sales that might create support obligations that you can't fulfill. All right, so how do you handle games that are part of a larger ecosystem, such as shared accounts across multiple games? Shared ecosystems require some special consideration. Data export and import tools for one-time migration. For example, if you're using a MySQL database, you may export the tables and schema, but not provide any of the user data that's private, so it can be used on community servers. Converting shared currencies to local alternatives. You can take a copy of the data and convert it to work with one game at shutdown. Other games still in support can keep using the shared account structure. Legacy bundles that give everyone previously cross-game content. This would remove all the need to do ownership checks with a server, simplifying the preservation build significantly. And optional community-run federation models. Let the community host their own database server with accounts so the game is still playable with social features intact. All right, so how long should the final end-of-life game patch be available to download? Distribution availability does require long-term planning. Some practical solutions would be multiple distribution channels from day one, official checksums and digital signatures for authenticity, clear licensing that allows community mirroring, and specific platform recommendations like GitHub, archive.org, etc., with protection for legacy players who haven't updated yet. You'll want to keep in mind a timeline approach. 6 months for official plus community mirrors, 2 years for transition to community only, and 5+ years for archive services as primary. The goal is ensuring the preservation build remains available after you stop actively supporting it. Now, how do you provide a fallback experience for players who still launch the game post-shutdown? Graceful connection failure handling can replace error messages with helpful guidance about how to connect to community servers or access offline modes. You could use an offline mode implementation and provide alternative gameplay options that work without any server connectivity. You have community integration where you can connect players to community resources where they can find active servers, get help, and continue enjoying the game. The worst experience is a player launching a game they paid for and getting a cryptic error message. Instead, guide them towards ways that they can continue playing. All right, so we are going to talk a little bit about tips for existing games because we've seen those questions, but it is important to note that the initiative states it would only require new games to be built this way and does not apply to older games. However, this may be helpful for game developers who are taking their existing code base and are aiming on shipping it again in a new game in the future. When making a new game, the right decisions can be made from the start, which is much more cost effective than trying to retrofit preservation support into an existing game. But the initiative does not intend to be retroactive. With that out of the way, let's move forward. How would you decouple online and offline features if the game was not built that way? Retrofitting preservation support is very challenging, but possible. You'll want to document existing systems, create a detailed inventory of all game features, and categorize them as online essential. If it requires server connectivity or online enhanced, better with servers but can work offline. Offline capable works independently. So identify the absolute core gameplay loop that must be preserved in offline mode. Architectural modification strategies. So create abstraction layers between game logic and online services. These abstractions can switch between online implementation when servers are available and offline implementations when they're not, without changing core game mode. You'll separate online state like global leaderboard, social features, and cloud saves from offline state like local progress settings and single player content in your data models and storage systems. This is significantly more work than building preservation support from the beginning, which is why the initiative focuses on new games. Which brings us to a very important question. How do you design your next game to make end of life easier from the start? Prevention is better than a cure when it comes to preservation. Avoid unnecessary online DRM. Don't require online connectivity unless it's essential for the core gameplay experience. When multiplayer is essential, include things like LAN, direct IP, or peer-to-peer options as fallbacks. Always provide multiple ways for players to connect to each other. Plan for server shutdown ahead of time with an end-of-life plan. Document your preservation strategy before you need it. And separate game logic from online components as much as possible. Design your architecture so the game can run independently of cloud servers, and make sure you have a build flag for an end-of-life build. Test your preservation mode throughout development, not just at the end. Make sure your code and design patterns use a driver pattern. Build flexibility into your service connections from the beginning. Having this planned from the start will reduce costs significantly compared to retrofitting preservation support. Now, how much could it cost to convert my game to one that can be preserved? That's a question that we've heard a lot. Now, the cost varies dramatically based on your planning. Doing it from the start for a game that has well planned out architecture could be a few weeks to patch in direct connect IP options, fallout LAN servers, etc. And can be implemented as features are developed to massively cut down on cost and time. It's much easier to flip the switch later to patch out DRM, release dedicated server build, etc. Estimated cost could be 5 to 20 euro. Feasibility is considered easy. 2 to 6 months may be needed for a game that is not well documented, poorly planned with poor decisions made during the development process. It could require digging through legacy code, rebuilding client server architecture, legal reviews, documentation, and testing. It may need to pay to relicense middleware or rewrite parts that can't be reused easily. The estimated cost on the smaller scale could be 50 to 200,000 euro. The feasibility is really risky. This is why, again, the initiative is only focused on new games. One of the big reasons is the cost difference is enormous. All right, so from my end, that's all I've got for you. I'm going to go ahead and pass this over to Matt of Alderaan Games, and he's going to talk about a case study for his game, Path of Titans.
Okay, as mentioned earlier, I'll be examining Path of Titans to show how an end-of-life plan could work. You can see here's a game here. So for this slide, we've got a lot of microservices. So over the past 5 or 6 years making this game, we've had to add a lot of services. Most of these, however, are not needed for end of life. So we just need the core gameplay functionality to work. So you can hear things like anti-cheat and stuff like that, as per the previous slides, are not needed. We have our own game launcher, and this also has a lot of microservices. The entire launcher, though, probably could be removed, and people could launch the game executable directly. But this will likely be supported in the future because we'll ship more games. You can see here is a login screen. So what we could do is we could patch the login screen out, potentially, or have some kind of workaround where community servers could host their own database. You log into them. So here's our main menu for our game. You can see we have a lot of options here, for example. So we have a multiplayer, single player, community servers, and a store and stuff like that. So here is a slide of the microservices we've removed. So you'll just have single player and community servers. You can see here we also have the server list. So you can see down here on the bottom left, we added a direct connect option. So when the server list goes down, for example, players will still be able to direct connect to other servers. We have some skins in our game that you can buy for small payment. If the player purchases or skins, however, are difficult to manage, the game could be patched to simply allow all purchased content to be usable. That way you could preserve players' transactions and purchase what they paid for, but also while making the content available for the community. So in this case, we could patch the game to make all the ownership checks return true. You can see here is an example showing the in-game character editor where the premium skin is unlocked for all players. Meanwhile, the other skins are still editable on game. So here's an example of the game not gracefully handling a transaction from the store. So these are the things that are kind of likely to break when you patch out the services for your game. If the check is too hard to remove, we could easily add a error message like this, indicating to the player that's not working. So here's the friends list and kind of how it works in game. You can see here after our service has been shut down, you can see there's a retry warnings where it can't connect to our friends list. So we want to make sure here that the game times out and throws an error message to the player saying it can't connect to the friends list. The bug here is the game gets stuck loading forever. So that might be a bad sign to players. This is kind of another example where we have kind of this family tree structure where we have some character data. So this would be something that we could kind of migrate to a local database or something that could be run by community servers. So here's an example of the servers we would have. So the servers we host for our official servers currently are based on this Supermicro 1U. Here's an example of 6 I have in my basement at the moment, just for testing purposes. This server is a really decent server, and you can see that's very similar to kind of hardware you'd have currently on your PC. And with this server, we can host 4 to 6 instances of about 100 to 200 players. So a single one of these boxes that only costs around $3,000 can get you 1,200 players per server. For hosting 1,200 players, this is insanely affordable and more than enough to meet the server requirements, especially because players can host these servers on their own PC. But yeah, that's all from me, and thanks for watching, and hopefully this video helps you preserve your game and keep it working after shutdown. I know there might be a lot of additional questions we didn't get to. You might be able to leave a comment and we'll be able to get back to you on those, but we could potentially do another video in the future. But hopefully for some developers there in the audience that are looking for answers on how to preserve their game and how to keep things working, how is it even possible, hopefully we've tried to answer most of those questions. Thanks everybody. Bye.